Hello and welcome back. Before we start getting our hands dirty by writing Python code, I want us to take a look at one important way in which the Python programming language differs from other programming languages. And so in this video, we are going to learn about compiled languages and interpreted languages, and we will see the difference between the two by the end of the video. And so I'm going to start by talking to you about compiled programming languages. And when we say compiled programming languages, the simplest way I can put it to you is they are programming languages where the source code is entirely compiled into an executable file before the executable file runs on a target architecture. We will understand that very soon. And by source code, what I mean is the test that represents the program that we are trying to write. So regardless of whether we are using a compiled language like C or C++ or Golang or Rust, or we are using an interpreted language like Python, the life of our program or the life of every program start off being a source code. And like I said, the source code is the test that represents the program that you want to write. And of course, in these tests, you have to obey some syntax and semantics rules of the programming language that you are using. Okay, so for compiled languages, it goes through these steps that you can see on your left. The first one is, of course, you have to write your source code, and you have to make sure that your source code conforms to the syntax and semantic rules of the programming language that you are using. And once you have your source code, depending on the programming language, in this diagram, I am thinking of C or C++, okay? So it is not very different for other programming languages that are also compiled. There might be some slight differences, but the general idea is the same. And so your source code goes through another program that is called the preprocessor. And what the preprocessor does is to generate expanded code, because usually when you're writing programs, you make calls to other code that you didn't write but have been provided for you by other people or even by the programming language itself. And so the preprocessor is going to expand your source code before it feeds the expanded source code into another program called the compiler. And what a compiler does is to generate assembly code. And just in case you're wondering, what is assembly code? So programming languages have gone through several iterations to be where we are today. And in fact, the first form of programming was done in a language called machine language, where people basically used zeros and ones to write programs, because zeros and ones are the native language that the computer understands, where at the lowest level, one represents some transistor in the hardware being on, and a zero represents some transistor being off. This is the simplest way I'm putting it so that you understand at a very high level. Of course, the details at the low level are different, okay? So there was machine language, and as you can imagine, writing an entire program using zeros and ones wasn't very user friendly. And so they made an improvement and they came up with another language that was a bit higher level than the machine language. And when I say higher level, basically think in terms of something that is getting closer to human language, okay? And so in assembly language, what they used to write those programs was called mnemonics. And so mnemonics were basically shortcuts, words that were almost like what you know them to be in human language. For example, there are words like load, there are add, stuff like that. And so they moved away from zeros and ones, and they came into something that was a bit more easier for humans to understand. And so that was the assembly language. And so for these compiled languages, what happens after pre-processing is the expanded source code gets into the compiler, and the compiler generates assembly code. Okay, and the assembly code that is generated by the compiler gets fed to another program called the assembler. And what happens there is the assembler generates an even lower level code, which is actually getting closer to the machine code that I spoke about, or the machine language. And so the assembler takes the assembly language code that is generated by the compiler, and it produces the object file. Okay, and there is yet another program called the linker that basically puts together other libraries or other files in your program to generate what is known as the executable. So for those of you on Windows, you are familiar with the concept of .exe files, and you know that they are those files that you usually double click and then you get things happening on your computer. Those are the executable files, and these files are files that contain instructions that your architecture, and when I say architecture, I'm talking about a specific combination of hardware and operating system. Okay, so the processor type and the operating system. And so the exe contains instructions that your architecture understands, and that is how come it is able to execute them. There is one beautiful thing about compiled languages in the sense that because they go through all these steps from source code to pre-processing to compiler to assembler to linker and finally getting the executable, um, the, the, the process is able to catch bugs in terms of syntax errors, and sometimes semantic errors also are caught. And when I talk about syntax, think of the rules that governs what is valid in a language. For example, in English, I cannot say I didn't did it. It is syntactically wrong, okay? And so there are rules in English that governs how we can combine words to form sentences. The same thing applies to programming languages, and these things will become easy for you to understand once we start writing Python code. And so um, basically the compiled languages go through all these steps, and it is able to catch some errors for you. And so if there are errors in your program, the intermediate states are going to catch them, and the compilation is going to stop, so you will fix them before you actually have an exe. And so once you have your executable file, you are confident that at least your program does what you expect it to do. Of course, not all types of errors are caught at this stage, but at least syntax and semantic errors are regularly caught. Okay. And now I want us to talk about interpreted languages, of which Python is a typical example. And the difference between compiled and interpreted languages is usually clear in terms of how they get executed, okay? And to make you understand how interpretation works, I want you to imagine yourself talking to another person who doesn't understand your language, and you also do not understand the person's language. And so you agree with me that the way you can communicate with that person is to find another third person who understands both your language and the language of the person that you want to communicate with. And so you will say what you want to say to this third person who understands you and understands the next guy. And this interpreter is going to say what you said in the language of the other guy. So the communication is going to be step by step, one after the other, okay? And so, unlike compiled languages where your entire source code is compiled before you have an executable, interpreted languages work by executing your programs line by line. And so, um, it is prone to getting some errors during runtime because it doesn't go through the compilation step in the sense of the compiled programming languages. And for Python specifically, this is partially true because for Python, once you have your source code, which we will write in files that have the extension of .py, um, It is actually kind of compiled into an intermediate step called the bytecode, an intermediate representation of your program called the bytecode, which ends in .pyc, and we will see these files once we start writing code. And then we have another program that is called the Python virtual machine. And so the virtual machine is the guy who understands the Python source code up here, and it also knows how to speak to your underlying hardware, which is, like I said here, the architecture. So the combination of your hardware and the operating system that is running. And so the Python virtual machine takes in the bytecode and is able to generate machine instructions that your hardware is able to execute. This is very important for you to understand the different way in which Python behaves from other languages like C, C++, Golang, or um, Rust, like I mentioned earlier. And so this is just to help you to understand, just in case you come across anything that mentions compiled languages and interpreted languages, then you have a fair idea of how they differ from each other, and you also understand how Python is indeed an interpreted language. So thank you very much for watching, and I'll see you in the next.